Hey guys, this is the beginning of our summer learning packets. The first thing that I decided to start with for Algebra 2 is polynomials. We are going to start with factoring polynomials. It is a review of some of the things you have learned in Algebra 1, but it's been a while since we've been in class together, so I thought we might ought to start here. So remember that the factors of a polynomial when set equal to 0, find the solutions, the roots, or the zeros of the polynomial. We will have to do that when we get over to the quadratics section. So we're going to start with this one. First, we need to come over to the side of our paper, and we need to write down the factors of 20. You know, the factors are the things that we multiply together to get 20. So we would have 1 and 20, 2 and 10, 4 and 5. Now we need to look at those factors and we need to ask ourselves, which one of these could I add or subtract in some way to get -1? The answer would be 4 and 5. I need a +4 and a -5. So I will rewrite x squared minus x minus 20 as two binomials. Half of x squared would be x in my first binomial and x in my second binomial. And then I will have +4 and -5. So the factors of x squared minus x minus 20 are x plus 4 and x minus 5. We could check this by using the FOIL method or the box method to make sure that when we come back and multiply these two binomials together, we end up with x squared minus x minus 20. So that's what we call a basic polynomial. Now, if you look at this next one over here, it looks a little bit more complicated. We don't have a greatest common factor that we can take out. We have a 6 as our leading coefficient. It's the number in front of our variable with the highest exponent, and then we have a 2 as our constant. So in order to be able to factor this one, we're going to do something called factor by grouping. To start this factor by grouping, we need to first multiply the leading coefficient of 6 by the constant of -2. So we have 6 times -2, which is -12. So now, when we come over to the side of our paper to find our factors, we want to find two numbers that multiply to -12 and add to -1. So we'll come over here and we'll do -12, and we'll say 1 and 12, 2 and 6, 3 and 4. Well, to add to get -1, I would use a +3 and a -4. But I can't just write it down as two binomials. I have to rewrite the original so that I separate my -x right here into my two numbers that will add or subtract in some way to get me -x. So I'm going to rewrite my original as 6x squared plus 3x minus 4x minus 2. I haven't changed anything. It's still the exact same polynomial as I had at the beginning. I have just rewritten it so that I can now factor it by grouping. To factor by grouping, let's get a different color, yellow. To factor by grouping, I'm going to separate this into two binomials. So I'll have this one, and then I'll have this one. And I need to find the greatest common factor of both. So my greatest common factor of 6x squared plus 3x would be a 3 and an x. And then 6x squared divided by 3x. 6 divided by 3 is 2. X squared divided by x is x. Plus 3x divided by 3x is 1. close my parentheses. My greatest common factor between negative 4x and negative 2, if there's a negative sign right here, it's always part of my greatest common factor. So negative 2. Negative 4x divided by negative 2 would be positive 2x. Negative 2 divided by negative 2 would be positive 1. So one of my factors is 2x plus 1. And the other factor is 3x minus 2. So those are two different ways that we can factor polynomials. I know it seemed like we went a little fast, but we're going to keep practicing as we go on. So now we're going to factor quadratic trinomials. Remember, a quadratic starts with x squared. So if I look at this example right here, does it start with x squared? No. So in order for me to be able to factor it and turn it into a quadratic trinomial, the first thing I'm going to look for is a greatest common factor. So I look all across, and my greatest common factor is the greatest factor of all of the terms have in common. And we can have numbers and we can have letters. We can have both numbers and letters, or we could have one or the other. So if I look across, everything will divide by 2. So 2 is my greatest common factor as my number, and then they all have at least one x in common. So I'm going to start by taking out my greatest common factor. If you had me for Algebra 1 last year, what we did, let's erase this for a minute, is we took our greatest common factor of 2x and we showed that we were dividing everything by our greatest common factor. You don't have to do that, but it sometimes does help to see that extra step. So I write my greatest common factor down outside of my parentheses. 2 divided by 2 is 1. X cubed divided by x is x squared. Remember, when we are dividing with exponents, we subtract the exponents. So 3 minus 1 is 2. Minus 2 divided by 2 is 1 again. And then x, 2 minus 1 is 1. And then minus 40 divided by 2 is 20. And then x divided by x is 0. So now that I've taken out my greatest common factor, I have a quadratic trinomial. It's a quadratic trinomial because it's in the form of ax squared plus bx plus c. Now, can this x squared minus 20x minus 20 factor into two binomials? Absolutely. It was our very first example in this left-hand box at the top of the page. So we're just going to write down 2x, and we're going to borrow our answer from the top. So 2x times x plus 4 times x minus 5. And so now we have a quadratic trinomial broken down into its component parts. Now those are basic methods of factoring. We can factor some special situations too. One of the special situations is called factoring the difference of squares. It sounds hard, but it's not, I promise. Difference of squares, we know what difference means. Difference means subtract. So that means automatically I'm looking for a subtraction sign right here. And then two squares. Well, something that's squared is going to have an exponent of 2 or could possibly be a multiple of 2. It's something I can take the square root of. And every single time, if I have two terms in my problem and I have a squared term at the front and a squared term at the back, like this a squared minus b squared, it will break apart into a minus b and a plus b. So how do I figure out what a minus b and a plus b is going to be? Well, if I look at my example, 16x to the fourth minus 1, I take the square root of 16x to the fourth and 1. Well, the square root of 16x to the fourth, the square root of 16 is 4. The square root of x to the fourth is x squared, because I could multiply 4x squared times 4x squared and end up with 16x to the fourth. And the square root of 1 is 1. So 4x squared is my a term, because 16x to the fourth was my a squared term, and 1 is my b term because the 1 in my original was my b squared term. So now that I have my a term and my b term, I write down a minus b times a plus b. So I have 4x squared minus 1 times 4x squared plus 1. I have to be careful. Anytime I have two terms, like this right here, two terms, and a minus sign in between, I have to check to see if I end up with the difference of squares again. So can I take the square root of 4x squared? I can. The square root of 4 is 2, and the square root of x squared is x. Can I take the square root of 1? I can. It's 1. So look, I have another a plus b, a minus b situation. So really, this polynomial right here breaks apart into 2x minus 1 times 2x plus 1 times 4x squared plus 1. So we have 3 terms in our final answer. So this little note that's written at the bottom of your page, can factor the difference of two squares more than once. That's a very important thing to remember in Algebra 2. So that's our first page of some basic factoring of polynomials. Let's move on to our second page. This is all in the first part of your packet that you got in your summer learning. The second page, there's a big note at the top that says always look for a greatest common factor first. That's extremely important because if there is a greatest common factor, it needs to be taken out. So if I look at this next example, it has 4 terms in it. Well, we factored polynomials with 3 terms, and then we created a polynomial with 4 terms so that we could factor by grouping with our polynomial that had a leading coefficient of something other than 1, but this is our first one to actually have 4 terms. So the first thing I do is I look for my greatest common factor. I have a 2, a 1, an 8, and a 4. There isn't a number that all of those will divide by, so I have to group this polynomial into 2 sets. So my first set has 2x cubed plus x squared, and then my second set has negative 8x minus 4. Sometimes it's helpful to draw us a line like that. So then I come and I take my greatest common factor out of the first set. So my greatest common factor of the first set would be an x squared. I can do that by writing it all out in longhand. 2 times x times x times x divided by x squared, which would be x times x. What do we have in common? 2 x's. So my greatest common factor is x squared. So I'm going to write that down. X squared comes out of the outside. 2x cubed divided by x squared. 3 minus 2 is 1. And 2 divided by 1 is 2. Plus x squared divided by x squared is 1. Close my parentheses. If you remember from that first page, I said that if I have a negative sign right here in front of my second term, it always comes out as part of my greatest common factor. And then I have an 8x and a 4. Well, 8 and 4 will both divide by 4. So my greatest common factor of that second set is negative 4. Negative 8 divided by negative 4 would be positive 2x. Negative 4 divided by negative 4 would be plus 1. So this 2x plus 1 that ends up in my parentheses has to be the same. If it doesn't end up the same, that lets me know I quite possibly have done something wrong and I need to start over with my grouping. So I'll write my first factor down as x squared minus 4, my 2 greatest common factors. And then my last factor is 2x plus 1. Well, again, I have a binomial that has 2 terms. There's a minus sign in between. So right here I've written in blue for you, remember to always check a binomial with a minus sign to see if it can be factored more using the difference of squares again. So can I take the square root of x squared? I can. It's x. Can I take the square root of 4? I can. It's 2. So if that answers to be true, then that means I have an a minus b times a plus b situation. I have a difference of squares again. So really, my final answer to this factor by grouping is, this is my a term, x, and 2 is my b term. So x minus 2 times x plus 2 times my leftover factor of 2x plus 1. Final answer. So, it might be good, before we go on to this next set of sum of differences and sum of cubes, for us to skip over in our packet just a little bit and do some practicing of our factoring. So, let's see. Why don't you come here to this one? We'll call this one example 1. And let's see if we can factor this one. So let's look for our greatest common factor first. So I'll give you a minute to see if you can come up with that greatest common factor. Remember, it could be numbers, letters, or both. Did you decide it was a y? I hope so. And then we're going to take and we're going to divide everything by y. So y cubed divided by y is y squared. 3 minus 1 is 2. Minus 4y squared divided by y. 4 divided by 1 would be 4. 2 minus 1 would be 1y. Minus 12 divided by 1 is 12. And then y divided by y cancels out. So now I have factored out my greatest common factor. And I have a quadratic polynomial. So now I want it to look like y times my first binomial that starts with a y times my second binomial that starts with a y. So what's my next step? My next step is going to be to take my 12, my constant term, come over to the side, and I'm going to list my factors of 12. So 1 and 12, 2 and 6, 3 and 4. We did that on the first page. And now I'm looking for something that will add or subtract in some way to give me negative 4. Which one of these, 1, 12, 2, 6, 3, 4, do you think will add or subtract in some way to give us negative 4? Good. I'm glad that you decided it was 2 and 6. So I need a positive 2 and a negative 6. So y plus 2, y minus 6. And I can go back and I can check using the FOIL or